Well, it's great to see so many people, especially so early on Saturday. I'm super excited to be here. And well, I think I forgot all of the things that I wanted to say, but I'll try to do my best. So thanks a lot to all our sponsors and Women Tech Makers. Thanks to all of them, we are here. My name is Magda. I come from Poland. I came to Barcelona 4 years ago and to finish my master at mathematics. And I decided to stay for a while. Currently, I work at Neuralink. I'm a backend software engineer, and I'm building monitoring for infrastructure. So now that's in short about me, and a couple of questions to you. So how many of you have ever heard about serverless? Nice. And how many of you have ever used it? And how many of you use it on your daily basis? Okay, nice. So for the first time, I heard about serverless around 1 year ago. But in that moment, I was mainly focused on building Kubernetes monitoring and preparing my wedding. So I didn't really have time to try it. And around 3 months ago, I changed my team. And I moved to build cloud infrastructure monitoring. And my first task was related to serverless, specifically about improving our monitoring for AWS Lambda. And I was quite, well, impressed about the possibility that serverless gives you. And I wanted to play with it more, explore it. And that's why I decided to give this talk and share my experience with you. For this session, I would like you to learn a couple of things. The basic concept of serverless, what's AWS Lambda, and also when does it make sense to use it and where not. Everything starts from an application. When you're building your application, you want to deliver a great experience to your user. You want to have your application available all the time and to respond fast to your user. And basically what you need to run your application, it's very simple. You need an idea, and then you need to write the code for this, and then finally you want to share your application with the rest of the world. So you need to deploy it to server. First of all, you need to have it, right? And here you have two possibilities. You can buy a physical server, or you can use the one offered by cloud providers. And this term, cloud providers and cloud computing, we'll be using pretty a lot. So let's just define it quickly to be all of us on the same page. Cloud computing is the use of data center servers and software networks to dynamically allocate resources and run applications for remote users. And companies that provide these cloud computing platforms are called cloud providers. One of the biggest cloud provider, and the one that I'm most familiar with, is called Amazon Web Services, or in short, AWS. They offer really wide range of services and tools to help us, developers, to build our applications, and we will see a couple of them in a few seconds. Let's come back to our servers. We finally have them, right? But then there is still a bunch of things that you need to do with them. You need to configure them and install all the things required for your application. Then you need to keep it up and running all the time, even when your application doesn't receive any traffic. When you have more users for your application, then you should scale up your server. And you cannot forget also about applying appropriate security patches and monitor the performance of your server if everything goes right. So that's pretty a lot of things to handle, right? Especially for small companies or for individual developers. Because what you really want to do is just build your application. So wouldn't it be nice to just skip this part of server? And this is where serverless comes in. Serverless is a concept of building and running applications that do not require server management. Applications bundled as one or more functions are uploaded to a platform and then executed, scaled, and built in response to exact demand needed in that moment. So how does it work exactly? Cloud provider is responsible for executing a piece of code. They dynamically allocate resources needed to run your code. And the code is typically run inside stateless containers that are ephemeral. They may last just for a single execution. And the pricing is based on the number of executions and the resources needed to run your code rather than pre-purchasing compute capacity unit. So does serverless means no server? Well, not exactly. Servers are still involved into the whole process. But the difference is that you no longer need to worry about them because you are not managing them. The responsibility of managing servers falls into cloud provider. So you can just focus on your code. Serverless becomes more and more popular, and most of cloud providers have invested into them. And currently on the market, we can have a lot of different serverless solutions. And some people believe that serverless will become, in upcoming years, one of the most used cloud service. So now let's talk about the most popular, AWS Lambda. AWS Lambda is a serverless compute service provided by AWS. It runs your code in response to events, like HTTP requests via Amazon API Gateway, or modification into S3 buckets, or updates into Amazon DynamoDB. AWS Lambda runs your code in high availability compute infrastructure and manages the whole administration of compute resources, like server and operating system maintenance, automatic scaling, and also code monitoring and logging. You can use AWS Lambda to extend your existing AWS services, or you can build your own backends. All you need to do is supply the code. That's the promise from AWS. Let's see if this is really true. What do you need to do in order to use AWS Lambda? As we know from previous slides, we just need to upload our code. And the code that we need to upload is in form of one or more functions, and those functions are called Lambda functions. The life cycle of building Lambda function consists of writing a code for your Lambda function, then creating it in AWS, and then finally monitoring and troubleshooting it in cases needed. So now I would like to create with you our first Lambda functions. And what we'll do, we'll create a simple function that do an operation of converting Fahrenheit degrees into Celsius degrees, as I have problem with this calculation, and I want to resolve my problem with Lambda. This Lambda will expect as an input simple JSON with the number of Fahrenheit degrees that we want to convert from, and then it will do a calculation and return another JSON with the number of Celsius degrees corresponding to this to Fahrenheit degree that we provided. This Lambda will be invoked by HTTP endpoint, specifically GET, where in the query we will provide a parameter with the numbers of the degrees, Fahrenheit degree, that we want to convert from. Okay, so let's go and let's try to do a live demo. Let's see what will happen. Let's take our function. Then I need to change some resolution so you can see my screen. And okay, I will just reload to see if I didn't log out.
It's okay, the display, or you want it smaller?
Yes, yeah, it's okay. So to build our Lambda function, we need to go to AWS Management Console. We want to use a service Lambda, so let's type it, and we'll be redirected to AWS Lambda page. Well, the resolution is not awesome, but I hope you can see. What do we need to do? We will create our function. We'll create our function from scratch. For this, we need to provide a basic information, which is the name of our function, and then we will pick a language that we want to use for building our function, and then just create. AWS Lambda provides natively support for different languages that you can choose, like Python, Java, Node.js, Golang, Ruby, and probably some other that I forgot. Great. We have this awesome congratulations. Your Lambda function convert has been successfully created. So first of all, we want to put our code. Okay. So this, we will remove these hello words from Lambda, and we will put our code. What we will have in this code? We need to start from building a handler. Handler is a starting point of your function. So basically, whenever your Lambda is called, this is the point that will be called first. In this handler, we need to provide two very simple things: event and context. Let's start first from the event. Event is an object that has information about incoming event that trigger your function. So it's definitely something that you need to process this data. In our case, we will expect to receive JSON with Fahrenheit degrees. So what we are doing here, we are just taking this value, assigning it to variable, and then using this strange formula, we are converting it into Celsius. And finally, we are returning JSON with corresponding Celsius degrees to the Fahrenheit degrees that we provided. And that's pretty it. Now I need to save it. And now we need one more thing. We need to have something that will invoke our Lambda. And this is called trigger. Let's see if you can see. Here we have this message, add triggers from the list on the left. On the list on the left, we have a lot of different triggers. In our case, we will use API Gateway, and we could configure it from here, or just go directly into API Gateway and configure it there, and we'll do this. So here, I pre-configure an API that has a get method, and in this get method, we can provide a parameter with the Fahrenheit degrees that we want to convert from. And the only thing that we want to do here right now is to provide our Lambda, so this HTTP endpoint will invoke this. Right, so I need to put the name of our Lambda. For doing this, I just follow the standard step of LWS, how to configure this API that you can find. Okay, we have this, and now we need to redeploy our API to pick these changes up. Let's do this, and in a second we should have an URL to invoke our Lambda. Let's go to this URL. Okay, it's loading. Okay, we have this beautiful message because we need to provide a resource that I configure and the number of degrees as a parameter. Hopefully you can see this. It's here. So let's say I provide let's say 86, and let's hit it, and this is the 86 Fahrenheit degrees is equal to 30 Celsius degrees. So that's pretty it. We just created our first Lambda function. Let's see what else we can do with Lambda. So on this Lambda console, there is pretty a lot of things. We were on part of configuration, but there is the second thing called monitoring. So let's go there and let's see what we have there. Out of the box, AWS Lambda provides you some very useful metrics that you should definitely use when you're building your Lambda functions. The basic ones are invocation, which just says how many times your Lambda function was invoked. Then duration, which says how long did it take to run your Lambda function, and also some information about how many errors happen and success rate. So if you're building your Lambda, these are the basic things that you definitely should monitor. There are some more metrics, but we don't need to enter into them right now. And the last thing that I would like to show you here are logs. Because by default, you also have some logs information. We didn't put any log message into our function, but by default, you have information when your Lambda function started, when did it ended, and also some report, where here we can see, for example, duration. And for me, the most useful is the memory that was used for running your Lambda functions. So that's pretty it. We've just created our first Lambda function, and we could see how to monitor and get some basic logs information. Okay, let's come back now to our. I need to change the resolution. Right. Okay, let's continue with. presentation. So let's just quickly recap what we've done for building our Lambda functions. First of all, we pick up a language that we want to use for writing our function. Then we wrote a handler, which is a starting point of Lambda. Then we use event to interact with the information coming from the user. And I just realized that I forgot to mention a context. Context was a second parameter in our Lambda function. And this context has some useful information about your Lambda. For example, you can know what's the remaining execution time of your function, because each of the Lambda has a specific timeout defined. So I think this is very, very useful information. The other information are, for example, the max memory that you can use and some others. And the thing that we didn't see was that we don't have to manage concurrency, which is really, really great. If you have like 40 users clicking in the same time and invoking your Lambda function, then Lambda will be automatically scaled and will respond very fast. Another very important part is that there is no shared state between execution. So if I would like to know, for example, what was the previous value of the Fahrenheit degrees that the user provided, I cannot do this with Lambda. I would need to use some external storage mechanism for this. And then we could add logs information and see them with these other logs that I show you, the basic logs from the LWS. So now you know how to create your first Lambda function. Now the question is for what you can use LWS Lambda. In the internet, you can find really, really a lot of different use cases. I think one of the strangest one that I found was an API with Lambda to fetch the nearby Pokemon Go data. But I will talk about some more standard one. So Lambda is a great use case for stream processing pipelines. So imagine that you're pushing all new tweets into Amazon Kinesis, and then for each one of them, your Lambda is triggered, and it extracts tweets with a specific hashtag that you're interested about. So then you can, it's pushed. These statistics are pushed into Amazon DynamoDB, and then you can use them, for example, to see some nice trends or see some graphs. Another use case is mobile backends. Imagine that you have a user that sends a message to her feed into your application, and then this message hits an HTTP endpoint configured via Amazon API Gateway. And then Lambda fetch all the subscribers of your user and then sends a notification to all of them through Amazon SNS. And web apps. You can build backend for your web application. And to have idea how exactly you can do this, I would like to share with you my application that I created for this demo. So what is this? I have a website, static website, with where it's hosted on Amazon S3. And then this website is doing image processing. So when you upload your photo, then it hits an HTTP endpoint, and then it's routed to Lambda. Lambda, what it does, it's resize of the image, and also is applying an effect that you picked. It returns back this modified image, so you can see it in a browser, and it also store this information, store this new image into S3 buckets. And then there is a second Lambda. The second Lambda reads the images from the bucket and then put them all together into one image. So we have like some kind of mosaic image, and then finally we have a link, a URL of this image, and we can see it in our browser. So now I would like you to try this. So you can scan it and you can explore if my application will broke or whatever. So let's see what will happen. I will wait a while. I hope that you can scan and you are redirected to my my basic website. I'll also show how I'll do this. Yeah, is it working? Are you redirected to the website?
Yes.
Okay, cool. Okay, so I'll go also, and I need. Okay, I need to change the resolution. Just a second. Okay, the website has very basic front end because I still didn't learn front end skills. It's on my to-do list. What do we have here? So first, you can choose an image. Let's say I will choose my image. I'll put open, and my favorite effect is invert colors. So this is the original image that we have, and now this is the process image. It's resized, it's cropped, and it has this effect. Now, the second part is we could go to gallery and see if there are, wow, there are photos. There are our photos. So that's it. So this is my, my web application. If you upload more photos, then they will appear here. So you can see that Lambda is very powerful, and you can build a great web application. You can have couple of Lambdas doing single operation, and then connect it with other AWS services and build great, very scalable application. And it's also possible that they will cost you nothing or just a couple of euro if you don't have like a big traffic. Okay, let's come back. And did it work for most of you? Okay. So hopefully now you can imagine that Lambda is pretty powerful, but there are some use cases when it's not really recommended. First of all, if you have some long-running task, then you should not use it. For example, when you're doing some complicated query into databases, or you're doing or you're calling external services and you need to wait for the response. First of all, it can cost you a lot, and the second thing is that there is a specific timeout, hard timeout defined per each Lambda, and after the timeout, the Lambda is just killed. So you should not use it for long-running tasks. Another thing is that there is a hard memory limit in Lambda. So if you want to do some complex compute operations, like performing some hard machine learning task, or converting or processing a huge video, or anything that requires to upload a lot of data into memory, then don't use it. And finally, you should not just load your standard Rail application as it is, because you will be limited also on the deployment package size. So time for some takeaways. I'm a pretty beginner user of serverless, but I noticed a couple of things. Lambda is not the silver bullet. Being serverless doesn't mean that there is no configuration. There is still a lot of configuration involved, as having just Lambda is not enough. You need to connect it with other pieces. And these other pieces you need to configure, apply proper permission, and so on. And being cheap for a single execution doesn't mean that you can just relax and don't watch the overall cost of your infrastructure. You should definitely watch it. But Lambda is something that you should definitely try and play with it. It can be a great use case for doing prototypes, for simple streaming or processing pipelines, or for web application, as I did. The community is growing, and serverless becomes more and more popular, so there are more tools, and the goal of this is that there will be much more easier to create our serverless application. And in the end, Lambda promises you to be very cost effective, to be automatically scalable, and to make you focus just on your code. And if you feel that automatic monitoring is not enough, then reach out to us at New Relic. Thank you. So, any questions?
One question. If you made two lambdas,
Mm-hmm.
the first one can do something and call it to other one with the result of the lambda?
Yes, for example, well, what I did was in my case was not directly calling another lambda, well, I'm not sure exactly. Usually it's through HTTP. Mm-hmm. We have more better expert.
So in general, because you're building a distributed system, you should always put some kind of queue or some other kind of element in the middle. So a good practice to connect to Lambda is to put a queue in the middle, or to put a stream, or to put a database, and then trigger that other Lambda. So then the execution is independent and they are not highly coupled together. So you can call two Lambdas together, it's not a good practice. So AWS SDK provides you tools to call two Lambdas if you want to, but don't do it.
Yeah, and usually it's. I was seeing a lot of different examples, and I haven't seen that there were two lambdas.
Yeah, they kill the developers that do that.
Oh, okay. So maybe that's why there are no examples of this.
So it's not a good.
It's not a good practice. No,
Okay,
because
make a
as soon as you
presentation with
start,
Lambda.
as soon as you start trying that in production, then you realize it's kind of it starts to get very tangled together. So it's better to put a queue and then start buffering your calls, and everything flows much easier.
Regarding on that, so yeah, okay. So as you say, there is not a good practice to concatenate lambdas. Is there another bad practice that you know? I have to that you know that where it's not also a good practice to apply lambdas?
So the example that I had, for example, long-running task.
Okay.
So this is definitely not a good practice, right? And the other two that I mentioned, because their lambda has some limitation, and basically you should think about them. For example, the basic limitation is a timeout. As maximum you can have, I think it's 15 minutes. There are also the memory limit, the deployment package, and yeah. So these are the cases that you definitely should not use lambda. Or you can, for example, for a long-running task, you can use it, but it can be very, very expensive for you. So probably you don't want to do this.
Okay, and just another question. Which will be the advice that you will give to people that want to start with lambdas?
Mm-hmm.
It will be a good way to start with. For the one that, as you say, there are many examples on internet, but what do you think will be the best one to the ones that wants to start with it?
For example, for me was building this web application, this serverless, because well, this is something like super visual, and maybe you always wanted to build your web application, but you didn't know how exactly to start. And there is a lot of support to build this web application. There are also tools. I didn't mention the framework Serverless that. It's very helpful to start using this. So you can Google the serverless framework and also start with it. Yeah.
So, thank you. There is another question? Okay.
What's the difference between platform as a service? What's the difference between serverless and platform as a service?
Well, serverless, in fact, is a huge context, right? Lambda is just an example, right, of one part of serverless, right? But as I saw, Lambda is not enough. You need to connect it with these other pieces, right, needed. And this whole thing is showing you the serverless applications. I don't know if I answer your question.
More questions?
I saw that in your example, it says like 100 megabytes, and it's just a one function. And is there a way to optimize that?
Yeah, this is something that I definitely have on my list. The first function, I don't know, because there are two functions, right? The first function is pretty fast, or the long part of what is taking on the website is that you need to upload an image, right? So my Lambda will pick it up. So the first Lambda it should be pretty fast and good. The second Lambda is not good because I'm picking all of the images. And if there is more and more images, then I need to process them all. So my optimization for this is that I need to have some storage, external storage, and not to read all of the image every time, just read the last image that came and put it into my mosaic. So if I do this, then it will be faster. It's very slow because I read all of the images, which is not good. But that was just for the demo purpose.
Any more questions? No?
Come on, we have time.
Don't be shy. Okay, I have one. Just to start the conversation. I think I can speak very loud.
There?
Oh, we have one there. There.
Okay, so
You know?
Hi. You said that you were more into Amazon. What about Microsoft Azure or Azure? I don't know.
Mm-hmm.
Is there also a Lambda here?
Yes, Azure, it's called, I think, Azure Functions. I didn't try it, but yeah, it's also popular, and I think it works. There are tools like Serverless Framework, and the goal is to work with different serverless functions, not only with AWS. It's probably that there are some differences. I've never used it, so I don't know. I know that there are differences in prices, for sure, and probably some internal as well.
Use my question. So the biggest problem we had with using AWS Lambdas was the monitoring, and the monitoring that we're doing besides the one that they provide by default. So anything you want to see from your application, pushing some events outside, logs, it was like very complicated. Even the logs that you showed, it's really hard to find something there. You have to go to each on all of them. The indexing is not very helpful. So I'm curious on your experience, like did you have this problem, or it's like
Well, we are building in New Relic monitoring for AWS Lambda. It's right now, I think, in the private or public beta, so we'll be releasing soon. But yeah, one of the problem of Lambda is generally monitoring, because it gets very complicated as you have a lot of different pieces, and if you want to find something, it's hard. So, well, if you want, I invite you to this stand. I can show you some things that we have. I didn't have time to show it here.
Thank you very much.
Any more questions?
no questions?
No? Okay.
Okay,
So
so
thank you, Magda.